Hello, hello. Yes, now we got it. Welcome again, dear visitors. Welcome also the online visitors who are here via live stream. Welcome to the Hydrogen and Fuel Cell Europe. I'm sorry, it's the repetition which makes me laugh a bit. It's many times. We have a very interesting presentation, and it's about industrial equipment and thin film coating solutions for fuel cell applications. And the speaker is Industry Manager Fuel Cell. The company is von Ardenne. Please welcome with an applause, Susann Puppe.
Oh. Good morning to the audience. Thanks for joining this presentation. I'd like to get my first slide. My name is Susann Puppe. I'm active in the field of fuel cell and hydrogen applications for several years now, being responsible for sales and business development for von Ardenne. Today I want to give you an introduction into von Ardenne and its industrial equipment solutions and thin film coatings for fuel cell applications. Just to give you an overview about the operating figures of von Ardenne, order intake and revenues are on average 250 to 300 million euros. We are managed and owned by the family von Ardenne. Pierre von Ardenne is the CEO. We have grown from an institute size for roughly 90 years ago to nowadays 1,000 employees as an industrial corporation. And due to our technological background, we own over 650 patents worldwide. The global network of von Ardenne is basically consisting of sales and service subsidiaries located in our major markets or close to key customer sites for fulfilling our service promise. So far, we have sold more than 500 coating systems installed in over 50 countries. We have an export quote of roughly 90–95%. So, what exactly are we doing? We are manufacturer of advanced vacuum coating systems with applications in a very broad range. Very thin coatings means coatings from 1 nanometers to few micrometers thickness, giving surfaces completely new functions. Could be conductive functions, can be passivation functions, decorative, anti-scratch. It's very diverse. That means for covering all these applications just shown, we of course can design and engineer machines that can handle all kinds of substrates. That can be 10 micrometers thick polymer foil only, up to 2 millimeters metal strip, can be very tiny substrates or glass paints up to a length of 6 meters length. Applying these functional coatings, we are using 2 core technologies, which we have expertise in for decades now, which is the magnetron sputtering, and the other one is mainly the electron beam evaporation. We are configuring the machines to all kinds of needs. Could be demand for R&D purpose, for institutes, industrial labs, universities. We offer machines sized for pilot production, or here you can see mass production machine, in this case a glass coater. Coming to fuel cell application and also for electrolysis, the functional coating our equipment is applying is dedicated to the bipolar plate. in a fuel cell stack, you have around 300 to 400 bipolar plates stacked in a fuel cell stack, depending on the power output the stack in the end would need to perform. Of course, main discussions over last years have been taken for the PEM fuel cell stack, especially for the metal bipolar plate, but recently and latest trends also show very high interest in other components, functional coatings on other components, also for the electrolysis application, for instance. We can also cover such requests. So precisely the bipolar plate needs to fulfill certain demands of performance. We need high conductivity, we need mechanical stability, of course, low coating costs are expected, and corrosion resistance, and a long lifetime. Talking about the metal bipolar plate, we do need coatings to actually make the steel or titanium perform exactly these requirements. And this is where our PVD process is coming into the game. Within our platform of machines, we do cover, again, all demands. We can serve your nowadays R&D purpose for fuel cell investigations, up to pilot production, or even high volume production. What is important is the takt time of production, especially for the mass production, and the cost of ownership or the coating costs in the end. Means with our machines and our solutions, you can easily reach these targets. Okay, our engineering capacity and coater platform actually gives us a chance to cover two positions in the value chain, in the typical value chain of a metal bipolar plate. It starts with a metal strip coil, of course. And if you're coating single sheets, means the readily welded bipolar plate, that's called post-coating. This is done by loading on carriers and then running through the coating process. Another approach, and basically the economically more feasible version in the long run, is a pre-coating option where you actually coat the coil, and the following steps in the value chain are following: cutting, stamping, welding afterwards. So now combining these two, the post-coating and the pre-coating of the substrates, and then our two core technologies, electron beam technology and sputtering, you have a very diverse field of machine concepts that are possible to cover your production amounts. You can see here again R&D, metal strip batch coating, for instance. This is a mass production metal strip coater. This is just examples. It's a wide variety, and we are willing and very able to discuss your certain needs and adjust that. Not that we are only configuring machines in certain sizes separately, we can also, our machines are designed on a modular basis. We can install all kind of processes you would need. May it be any pre-treatment, any post-treatment. If you want to apply one layer or different materials in one row, we will just adopt that and just put that in a row of components. And this same machine can actually be upgraded. If you decide to double your productivity later on, we will just apply more components. So I will just show you a video on this one, makes it more visible. For instance, you would start with just a one-ended, one-carrier machine, carriers running into the machine, being coated, and running back. So that would be the initial stage for R&D. Then you can combine different components and compartments, working maybe with a magazine solution, front and back end, and it's still the same machine, just extended. And the latest extension version would be fully automated for loading and unloading, plus a carrier return system. So this is complete mass production. Also in our market, I think we are to a big part in the investigation and qualification phase, and therefore von Ardenne is able to do prototyping with you, do trials with you. We can also scale R&D topics up to industrial production. We do have a pool of lab machines in-house to cover your special requests. You can just approach us, and yeah, we are very willing to have discussions on new approaches. Just in case you do not have your own developments on a certain layers for performance, we did some investigations on a suitable layer stack that's possible for providing exactly the performance needed for the metal bipolar plate. This is a carbon-based layer stack. We have investigations with customers and also with institutes. It's comparable to the gold standard. Gold coating is basically the benchmark nowadays, but just commercially not feasible in the long run. So, and this layer stack, basically, this is just some really technological overview now. Department of Energy is giving certain targets for conductivity. We did a corrosion resistance test. The green columns, again, are the gold standard, or the benchmark, and the gray columns show our results. And we are pretty much on the same level as the gold standard. So just with this certain approach of layer stack.
So I guess there are lots of questions.
Yes.
Lots of questions, and you can ask Susann Puppe at her booth.
Yes, exactly.
It's D63.
Let me just show you. We have a shared booth with biotechnology and Zeltwanger, and just to finish my presentation, I can do that also at the booth. Please visit this fuel cell corporation at D63. Thank you.
Thanks a lot, Susann Puppe.